Hello, hello students.
Hello sir, good morning.
ओके सो आवाज आ रही क्या भाई? हाँ, हेलो, मेरी आवाज आ रही है?
Yes, sir.
हाँ
डू यू हियर
सर।
मी? एनीवन कैन आंसर? हाँ, ओके. Now let us discuss the most another important device in the power electronics family. No doubt the SCR is a very important device which is very widely used. Uh, if I ask you what is the disadvantage of SCR, whether it is a bidirectional or unidirectional, yes. Hello, students.
Yes.
Hello.
Hello.
अरे यार, it is a bidirectional or unidirectional SCR.
Unidirectional.
So
Unidirectional.
yes, it is
Unidirectional.
unidirectional. Perfect. Yeah. So that is the not important disadvantage, but it is one of the disadvantage of the SCR. Okay. If I want the current to flow from cathode to anode, it cannot flow. Understand? Because for the SCR to conduct, I have to make anode positive and cathode negative. Okay, I have to apply the forward voltage in such a way that positive battery should be connected to anode of the SCR and negative of the battery should be connected to cathode of the SCR. So ultimately, SCR is a unidirectional device. It is not the bidirectional device. Now, sometimes there may be application of the power electronics device which should conduct bidirectionally, right? So in that case, SCR is to be replaced with a Triac. Triac is a device which shows the characteristics in the first quadrant as well as in the third quadrant of operation. In short, I can say voltage across the device will be positive, current through the device will be positive, that is called as operation in the first quadrant, whereas the track can be operated in the third quadrant. It means that the voltage across the SCR can be reversed, means it's a special type of SCR, not the SCR, the track. And you can reverse the direction of current flowing through the device. Okay, that's why it is called as a track. So basically the term track is derived by combining the first three letters of the word triode and the word AC. As you know, AC is a bidirectional. Understand? AC is bidirectional. It means that direction of the current is get reversed in the AC environment, right? So if SCR is conducted, SCR is placed AC, it will conduct only in the positive half cycle, whereas SCR will be operated in the blocking mode in the negative half cycle of the applied AC signal. So that's why we are using the device track named as a track, which can be used in both ways. So it can conduct in positive half cycle of the applied voltage as well as it can conduct with the uh, negative input cycle. Okay, so that's why it is called a track, which can be used in positive half cycle as well as the negative half cycle. It means that the track can be used in AC environment. That's why it is called as a track. So basically, no doubt. If I ask you, track is a voltage controlled or current controlled? Yes, track is also the current controlled, right? Track is also the current controlled. Understand? Right. So track is also the current control device. Basically, okay. So in negative half cycle as well as in positive half cycle, there is a terminal gate which can control the flow of current. Now, here what makes it possible? If you see this layer diagram of the track, if you see the layer diagram of this track, you can see very easily, right? So, in this case of the track, terminal, Okay, so here also you can see the terminals are not labeled as a anode or cathode. It's not labeled like that because when you see about the anode, that it means that we can say because the terminals of the triac anode or cathode is here. Instead of that, you can see the terminals of the triac are labeled as T2, M1 means T2, MT1, MT2, MT1, and हाँ अभी आवाज आ रही है भाई? ओके। हाँ मिलन।
Yes, sir.
हाँ नेटवर्क का प्रॉब्लम है। जस्ट hello. What is the track? Track is a bidirectional device, right? Are you agree with this?
Yes.
Hello. Yeah. Track is a bidirectional device. Present now पे क्यों नहीं जा रही है? What happened? Okay. So the terminals in the track are labeled as MT2, MT1, and the gate. Okay. No doubt, ACR, sorry, track is a gate control device, means it is a current control device. It can control the flow of current in positive half cycle as well as in the negative half cycle. Okay. अभी देख रहे बेटा मिनल
सर तुमचा आवाज खूप ब्रेक
स्क्रीन दिसते
होतोय.
तुम्हाला?
तुमचा आवाज खूप ब्रेक होतोय.
हा स्क्रीन दिसते का पण आता? स्क्रीन दिसायला लागली?
नाही
हो
सर, पीपीटी नाही दिसत आहे.
स्क्रीन दिसायला लागली का?
नाही दिसत
नाही
आहे.
एक मिनिट एक मिनिट आता दिसते स्क्रीन? सांगा बरं मला.
नाही सर.
हेलो बेटा स्क्रीन दिसते?
No, sir.
नहीं दिसत है?
नाही.
हाँ दिख रहा है क्या? ऐसा
No,
नहीं
sir.
अरे अरे, क्या हो गया यार? हाँ जस्ट वेट ऐसे ही ऑनलाइन बोले तो टीडीएस जॉब. अभी अभी दिख रहा है तो मिनल?
नाही सर.
आता
No,
आलं का
sir.
वर?
नाही येत आहे
बरं,
अजून.
इशू क्या हो रहा है आज? अभी बोलो मिनल, आता दिसते का बाळा?
हो
हॅलो.
सर आता दिसतंय.
हा
हा आता दिसतंय.
हा हा, थोडा जर प्रॉब्लेम झाला ना समजा, तर आय विल बी एक्सप्लेन दिस लिसन टू द व्हॉइस बिकॉज मे बी द पुअर रेंज ऑफ नेटवर्क. ओके, तर मी काय लक्ष एक्सप्लेन करतो ते फक्त लक्ष द्याल तुम्ही. तुम्हाला पीपीटी मी शेअर करतो नंतर ईमेलवर, ठीक आहे? तुमचा प्रॉब्लेम झाला तर बघूया, आपण रेक्टिफाय करू. ओके, सो व्हॉट इज अ ट्रॅक? ट्रॅक इज अ बायडायरेक्शनल डिव्हाइस. आय अग्री विथ दिस. हॅलो.
Yes, sir.
येस सर.
Okay. Basically, it can conduct in first quadrant as well as in third quadrant. Okay. So current can be positive as well as current can be negative, as well as voltage across the SCR can be a positive voltage as well. Voltage across the device can be the negative voltage. Okay. Now here from the curve you can see very clearly is that when the current is more, gate current is more, from these characteristics you can see very clearly when gate current is more, you can see the device turns on very quickly as compared to the gate current when it is less. Are you agree with this? Okay, so here you can see when Ig equal to 0, right, the requirement of the forward voltage required is the more as compared to this point, right? So ultimately the voltage at which the device turns on is inversely proportional to the gate current, like in the SCR also. This is the situation. Okay, next. Now here you can see the number of layers are number of layers are there. That's why it makes it possible bidirectional flow of current. Here you can see PN. Okay, so again this T1 is connected to P as well as this N. This gate is also connected to this P as well as this N, whereas this T2 is also connected with this P layer as well as the N layer. Now question arises why it is possible, why it is done. Basically it is done for the conduction of current. Means sometimes T2 can be positive, sometimes T2 can be negative, sometimes T2 will be negative, sometimes T2 will be positive. Similarly, T1 can be a positive, T1 can be negative. Understand? So, depending on the polarity applied to the T1 and T2, depending on the polarity applied to the T1 and T2, my gate current requirement changes. So, in this case, my gate current can be a positive as well as the negative. Understand? That's why this structure is there. So you can see the same structure is viewed in the three-dimensional view. Okay, nothing is different. Okay, so it is a three-dimensional view. Basically, when the tracks are prepared, it is prepared with the pallets. It is prepared with the pallets. So you can see here the gate terminal is connected with this N3 as well as the P2. Understand? Similarly, this MT1 is get connected to the N and the P2. Similarly, this MT2 is connected here. So ultimately, what I makes to trying to say is that it is possible, flow of current is possible only this kind of the structure is there. Understand? That's why. So basically, what are the advantages of track? The track has the following important advantages. They can be triggered with positive or the negative polarity voltage. Are you agree with this? Hello students. Hello. आवाज आ रही है मेरी?
Yes, sir.
Hello.
हाँ सर.
Yes, sir.
So they can be triggered with positive or negative polarity of the voltage. That is an important advantage. Are you agree with this? Okay. Secondly, they need a single heat sink of the slightly larger size. Okay, because you know that those all are the devices are the power electronics devices. If you see the SCR, there also you can see the availability of the heat sink connected to that. So basically, heat sink is used. What is the purpose of using heat sink? Heat sink is used, right, to maintain the temperature of the device. If heatsink is not used, you know that, right, the temperature of the device will be very large and that may damage the SCR. Understand? And that may damage the SCR, and that is the use of the track. Secondly, they need a single fuse for protection. They need a single fuse for the protection, which simplifies their construction. Understand? So in that another one is that in some DC application, SCR has to be connected with a parallel diode for protection against the reverse voltage, whereas Triac may work without a diode as a safe breakdown in the either direction is possible. Now, basically, Triac is nothing but, if you see this symbol, right? Triac is nothing but the two SCRs connected in anti-parallel. Understand? And that's why here the SCR needs the diode to be connected in parallel. That is a protection circuit part that we will be covering afterwards, right? But as such, there is no need of the diode connected in parallel in case of the Triac. That is the important advantage. Now, as far as Triac is concerned, the Triac has a bidirectional thyristor, has various applications. Some of the popular applications of the Triac are as follows. It's been in speed control of single phase AC series or universal motors. Okay, the Triac is used because you know that when you are controlling the speed of the single phase AC series or universal motors, basically there are the number of ways, number of methods to control the speed of the motor. Understand? Basically, in that, if I won't go much detail, there is a stator voltage control technique in which you are controlling the voltage applied to the motor. Then there is a frequency control called as the V by F control, right? Then rotor resistance control, right? All these are the techniques to control the speed of the AC motor. And when we have to control the voltage, when we have to control the voltage of the AC motor, right? Ultimately, you can control it, right? You can control it with the help of the Triac. Now, you must have seen or used the regulator that is used connected with the fan. What is the fan? Fan is a AC motor, isn't it? Fan is the AC motor. Okay, so in this AC motor also, right, you are controlling the applied voltage given to the motor or given to the fan. And when you moving the regulator, so ultimately what you are doing? In moving the regulator, you are controlling the voltage applied to the motor. Understand? You are controlling the voltage applied to the motor. Okay, so that is the major application of the Triac. Or it is also used in the light dimmer circuitry in association with the Diac. Diac is another device that we will be studying. So in association with the Diac, Triac can be used as a light dimmer. Triac can be used as a light dimmer in association with the that you are using the okay. So in we can control the applied voltage. Okay, in food mixing, Triac can be used in light lamp dimming as well as in zero voltage switched AC relay, right? In zero voltage switched AC relay, the Triac can be used. So these are the important major applications of the Triac. Okay, next. Okay, now let us see the diode. Now, as the name suggests, diode is also the bidirectional device. Diac is a combination of the two diodes, right, connected in anti-parallel, right? So, diode itself is a unidirectional device, but just assume that you are just connecting the two diodes in anti-parallel. What is meant by anti-parallel? Anti-parallel in the sense that just opposite way, understand? Just opposite way of the diode. So if it is connected left right, anode and cathode of the diode, if are another diode connected in parallel in the way cathode and anode. So just imagine what will happen. Current can flow from the first diode, which is connected anode to cathode in positive cycle, whereas in negative cycle, current will be connected from anode to cathode in another diode. Understand? Which is connected in anti-parallel. So now understand what is the meaning of anti-parallel. Parallel means two anodes are shorted and two cathodes are shorted. Understand? Of the two diodes, then it is called as a parallel. What is meant by anti-parallel? Anti-parallel in the sense that anode of the first diode is connected with the cathode of another, and cathode of the first is connected to anode of another, which is called as the anti-parallel connection. So diac can be think of it is the anti-parallel, two diodes connected in anti-parallel. So diac is a bidirectional device. Are you agree with this? Right? Is desired two diodes may be joined in parallel facing different directions to form the diac, which is called as the anti-parallel. Is it clear? Which is called as the anti-parallel. Are you agree with this? Hello? Hello students?
Yes, sir.
Yes,
Okay,
sir.
it is as good as two diodes connected anti-parallel. Okay, so uh, if I ask you, this is a current control or voltage control, can you answer? Let us see.
Voltage control.
Basically, it is not the control device. Okay, there is no control terminal, the gate, as in the SCR or the triac. So this is uncontrolled one. This is the uncontrolled one. Okay, whenever the required voltage will be obtained across the two terminals of the diac, right, it will conduct. Right, when the required voltage across the diac will be obtained, when the required voltage across the device will be obtained, right, then it will be called as the uh, in that case it will conduct. Okay, so you are not providing the facility of another terminal, we are not providing the facility of another terminal to be connected or to be used, which will control the flow of current from one terminal to another one. Okay, so basically diac is a not control device. Yes, diac is a bidirectional device like the triac, not the unidirectional only. It is a bidirectional, but the difference is that it is not the control device, right? Because the control terminal is not provided. Only two terminals are there, right? Like the gate, you can see in the case of the SR and the track, it cannot. It is not the control device. Okay. So this is the one diagram with the help of which you can see. So the construction of the diac looks like a transistor, but there are the major differences. All the three layers PNP or the NPN are equally doped in the diac, whereas in the BJT there is a gradation of the doping. Okay, so what does it mean by the gradation of doping? There is a doping level is being changed. That's why it is called as a gradation of doping. The emitter is highly doped, collector is lightly doped, and base is a moderately doped, as in case of the BJT. But that is not the case with the diac. Okay, they are all the three layers PNP or the NPN are equally doped. So basically, there is a sandwich of the layers. There is a sandwich of the layers in diac. Okay, so one structure will come into picture when positive and negative. Another structure will come into picture when there is a negative and positive, like that. Okay, that's why diac can conduct in the both direction. Here, diac is a two-terminal diode as opposite to the BJT. BJT is a three-terminal device. Now here you can see the if you see this waveform, my applied voltage is there. Sinusoidal wave is my applied voltage. Understand? This is my sinusoidal voltage. Now here you can see at this point of time, right, when there is a required voltage which is equal to the breakover voltage is obtained, right, in this case when there is a required voltage equal to the breakover voltage is obtained across the uh, two terminals of the diac, it starts to conduct. Understand? So you can see one waveform or one signal level. It is the input, another is the output. This one is output. So at this point, my diac starts to conduct, isn't it? At this point, my diac starts to conduct. Then it conducts till input voltage becomes zero. Conduction stops. Are we agree? Conduction stops. Again, it can conduct in negative direction, but it will not start to conduct at the zero voltage. Means at the crossing level it won't conduct, because some voltage again is to be developed across the diac. Yes, no doubt. It is a positive. In positive half cycle here there is a negative voltage which is to be developed. Here you can see this is a negative voltage is to be developed across the diac for the conduction to taken place. Here the positive voltage to be developed across the diac for the conduction to be taken place. Now understand. So one waveform is my input cycle, another is my voltage across the load, I can say. Understand? So here this voltage is called as a breakover voltage. Understand? This voltage is called as my breakover voltage when conduction starts. When conduction starts. Are you agree with this? Hello students. Any doubt? Hello. Any doubt?
No, sir.
Bolo? देखो again I'm repeating, this voltage is necessary to be developed across the diac for the conduction to be started. Are you agree with this? Okay, so it is as good as Ig equal to 0, because no gate terminal you are using here. There is no gate terminal. So when there is no gate terminal is used in this case, right? Ultimately, when there is no gate terminal is used in this case, ultimately you can say that, right, means uh, as good as Ig equal to 0. When it is Ig equal to 0, some finite amount of the voltage required to be developed across the diac, and that is developed at this level in positive way. It is developed in negative way in this case. So this is the positive breakover voltage and this is the negative breakover voltage. Now what is the main difference in a diac and the triac? In case of the triac, the positive breakover voltage and the negative breakover voltage is not same in case of the triac. But in case of the diac, this you can see here, positive breakover voltage as well as the negative breakover voltage both are exactly same, right? अगर मैं पॉजिटिव नेगेटिव में अप्लाई कर रहा हूँ डायक, ब्रेकओवर वोल्टेज इफ इट इज 25 वोल्ट, प्रैक्टिकल में हम देखेंगे. सो इफ इट इज 25 वोल्ट, in negative case also it is a minus 25 volt. Okay, so magnitude wise the uh, forward breaker voltage and the reverse breaker voltage, that is exactly same. Are you agree with this? Hello students.
Yes, sir.
Hello. Hello. Hello Vignesh. अनुराग, विवेक, विनय, तेज, जयेश, मिनल, वनिता.
सर आवाज ब्रेक होत.
आवाज ब्रेक होतोय, काय करायचं बा. थांबा. हॅलो. आता येतो का ग?
हा येतोय सर.
आता येतो नीट.
हा.
काय ते नेटवर्कचा इश्यू आहे, ऑनलाईन क्लासेस घ्यायचे आहेत. ओके ठीक आहे. समजलं का आता ब्रेकवर व्होल्टेज म्हणजे काय? So one question I would like to ask everybody: breakover voltage, the offset voltage or on-state voltage? Who will answer me this question? I'm asking breakover voltage, on-state voltage or offset voltage?
On state voltage.
Yes, Vignesh, काय बाबा?
साउंड ब्रेक होता
और अरे breakover voltage, on-state or offset voltage? breaker voltage is always off-state voltage, not the on-state voltage. Okay, fine, not the on-state. Right, it is actually a switch, no? Right, at this voltage, device turns on, and as soon as the device turns on, voltage across it reduced. Voltage across it gets reduced. So breaker voltage is always off-state voltage. Understand? ब्रेक और वोल्टेज इज ऑलवेज ऑफ स्टेट वोल्टेज. कभी आप बोलने का नहीं कि इट इज ऑन स्टेट वोल्टेज इज रॉन्ग. राइट. मिनल बाळा समजलं का?
हो हो
हॅलो
समजलं.
मिनल.
हा समजलं.
युअर ओके चला नेक्स्ट. ओके हॅलो.
सर तुमचा आवाज ब्रेक होतोय.
ड्रॉ अभी आ रहा है आवाज. ड्रॉ द कैरेक्टरिस्टिक्स. ड्रॉ द कैरेक्टरिस्टिक्स इन योर नोटबुक. अरे विघ्नेश आवाज येतो का रे? अरे विघ्नेश बाळा. साक्षी आवाज आ रहा है मेरा?
हाँ सर.
हाँ. You draw the waveform, okay? Sorry, characteristics. Okay. So here you can say in one direction current is labeled as positive IA. In another direction it is labeled as a negative IA. So negative current कोई negative नहीं होता है. Understand? You have to connect the meter in reverse way. Understand? तो current कोई negative नहीं रहेगा, right? Because it is a DC meter only you have to connect. Okay? आपका negative current नहीं दिखेगा multimeter पे. Next. Okay, you can see here this forward breaker voltage as well as the reverse breaker voltage, they are exactly same. They are exactly same. Next. Okay, now हितेश है का? हितेश स्क्रीन दिख रहा है अभी?
सर.
हितेश.
यस सर दिख रहा है.
मोरे अनिल. ओके ठीक है. हाँ. नेक्स्ट इंपॉर्टेंट डिवाइस in power electronics family, that is IGBT, insulated gate bipolar transistor. Draw this layer structure. This draw it layered structure. अब ड्रॉ करो नोटबुक में. ड्रॉ दिस लेयर स्ट्रक्चर. insulated gate bipolar transistor. Okay, over. Okay, say here again it is a insulated gate bipolar transistor. Okay, gate is there but insulated with SiO2 layer. That's why it is called as a insulated gate bipolar transistor. Basically, it has the cathode which is equivalent to emitter, and there is the anode which is nothing but the called as IGBT collector. Okay, so आवाज येतोय का? Do you hear me? All of you?
Yes. Yes, sir.
Hello
हाँ
student.
सर, अभी आ रहा है आवाज.
ओके, हाँ ठीक है. अभी आप देखेंगे. सो this is the IGBT, but I am just asking you, IGBT is a voltage controlled or current controlled? What we have heard about the IGBT? Yes, Hitesh Khade, Pradeep Khade, or somebody else, Vignesh, Vinay. Yes, it is
Voltage
a voltage
control
controlled or
device.
current controlled.
Voltage
Yes,
voltage
it is a
control.
voltage control device. Yes, yes, perfect. It is a voltage control device. Okay. Now, basically, if you see the structure of this IGBT is a something like the sandwich structure. Understand? It is a sandwich structure. It has the number of different layers. Buffer layer hai, drip layer hai, body layer hai, and the so many. Okay. Depending on the buffer layer, right? It is divided into the two type of the IGBT. One is called as a punch through IGBT. Another is called as non-punch through IGBT. Punch through IGBT and non-punch through IGBT. There is no need to go much detail अबाउट द पंच थ्रू आईजीबीटी एंड नॉन पंच थ्रू आईजीबीटी. उसके द्वारा ज़्यादा डिटेल में हम लोग नहीं जाएंगे, उसकी ज़रूरत भी नहीं है एज पर एज द स्कोप ऑफ द सिलेबस इज कंसर्न्ड. ओके ओके, बट बेसिकली इट हैज द डिफरेंट डिफरेंट लेयर्स. Okay, so basically IGBT is the improved version of MOSFET and is also the improved version of BJT. Understand? It is the improved version of BJT as well as the improved version of IGBT. Basically, it has the good qualities of BJT and good quality of the MOSFET. It's a combination of that. Okay, so the insulated gate bipolar transistor, as seen, is a recent model of the power switching device that combines the advantages of power BGT and the power MOSFET, just as I spoke about, right? जो जो अच्छी अच्छी क्वालिटीज है बीजेटी और मॉसफेट उसकी लेना चाहिए, दोस्तों से दोस्त करना चाहिए, बट दोस्तों अच्छे गुण लेना चाहिए, गलत गुण नहीं, ऐसे ही. Okay, so IGBT is the combination of the good qualities of the BJT as well as the MOSFETs. Both power MOSFET and IGBT are continuously controllable voltage control switch. Right? Just when I asked you the question, it is the voltage controlled switch. Okay, the voltage applied, right, between the gate and the source, between gate and the source will control, gate and the source will control the amount of current flowing through the IGBT. So it's the voltage control switch. The structure of an IGBT is shown the previous figure. I won't go much there again. The P region acts as a substrate which form the anode region, right? Means the which is the collector region of IGBT. Then there is a buffer layer of N region and bipolar based drip region. The P region contains two N regions and acts as a MOSFET source. This is my okay. So drip region, buffer region, and the upper one is a body layer. It is body region. You can say it is not mentioned in this. This is the body region actually. Okay. Here you can see N minus and the N plus. n minus and the n plus. What is the meaning of this? N minus and n plus, because we have studied the p region and n region. Then what is the bhangad like n plus and the n minus? So n plus means rich of electrons, which is very very highly doped. Understand? So deficiency of electron, that is n minus. Understand? That is the meaning of that, n plus and n minus. Okay. Now, the concept on which the IGBT works is called as formation of the inversion layer. See, the formation of the inversion layer is called as conduction modulation. The formation of inversion layer is called as the conduction modulation taken place, and that conduction modulation attracts the carriers, right, from cathode to anode, from source to collector. Understand? So that is the fundamental of working of the IGBT. Okay. So uh, here, probably in next lecture or afterwards when time permits, I will explain in much detail. Again, it is the not necessarily because we have to study the devices. But if time permits, I will dedicate this special lecture on IGBT, how the inversion layer is formed and how the conduction taken place. That I will explain in the special lecture on IGBT. Okay. For time being, we are skipping here because not needed that go in much detail how the inversion layer is formed and the conduction modulation taken place for the flow of the carriers and all. But one lecture surely I will be dedicated on this formation of inversion layer. Okay. So basically here IGBT operates in the two modes, right? That is very obvious: blocking or the non-conducting mode, the on or the conducting mode. Understand? Blocking or non-conducting mode, the on or the conducting mode. The circuit symbol for the IGBT can be seen in the sheet. It has a collector, emitter, and the gate. In some books, they referred as a drain, source, and the gate also. That is also not the wrong one. That is also the correct. Okay. It is similar to the symbol for an NPN bipolar junction power transistor with the insulated gate terminal replacing the base. Now, if you observe this symbol, in the symbol of BJT, you can see the gate is connected directly to this layer. देखो अगर आप बीजेटी का सिंबल देखेंगे ना बेटा, यहाँ पे डायरेक्टली वहां पे बेस होता है. अंडरस्टैंड? बट व्हाई इट इज सम गैप इज देयर? There's some gap you can see here, right? Especially this symbol itself indicates that gate is insulated. That is the meaning of this. Gate is insulated. Understand? Hello? Hello? Right? The gap itself indicates that the gate is insulated. This is the significance of the symbol. In BJT, you cannot see such symbol, right? The control terminal base of the transistor is connected directly. You cannot see the gap like that. So this gap itself indicates that gate is insulated. Okay. IGBT is mostly used in high-speed switching devices. Yes, very important. In power electronics, when the frequency is to be required very high, then the devices should switch on and switch off very at high speed. That's why in that case IGBT is used. They have the switching speeds greater than those of the bipolar power transistors. The turn-on time is nearly the same as in case of power MOSFET, but the turn-on time is longer. Yes, overall time is very very less. That's why they are faster. But if you combine, the turn-on time is nearly as same as in the case of power MOSFET, but the turn-off time is longer. The maximum converter switching frequency of the IGBT is intermediate between that of bipolar transistor and power MOSFET. Then what you studied here, the some points to be recalled. Thyristor is a multi-layer PN terminal. Okay. The thyristor is a multi-layer PN terminal electronic. PN terminal means not only PN. Understand? Thyristor, under thyristor family, there are the so many devices. Thyristor is a family, okay, in which IGBT is there, power BGT is there, power MOSFET is there, SR is there, and on so many. Okay, thyristor basically it is a multi-layer PN. Okay, so depending on the requirement, there may be a 3 layers of PN or 4 layers of PN and all. Basically, SR has a two states: high current, low impedance on state, low current off state. Latching current is defined as the minimum value of the anode current, which is must in order to attain the turn on process required to maintain the conduction when the gate signal is removed. Whereas holding current is defined as the minimum value of the anode current below which it must fall for turning of the transistor, for turning of the thyristor. So again, I am again repeating, latching current is associated with turn on process, whereas holding current is related with turn off process. Triac is a bidirectional device with 3 terminals. It is used extensively for the control of power in AC circuits. Diac is an NPN or PNP structure, uniformly doped layer. Why it is OR? Because if you are using negative positive, right? So depending on the requirement, IGBT is mostly used in the high speed switching devices. Okay, so power MOSFET we will be conducting in the next lecture. We will be covering in the next lecture power MOSFET and the power BJT, right? Then we will be moving to the protection or the rectifiers. We will start. Okay. So I know that attending the online classes is very difficult task. I mean, very difficult to pay the attention, but there is no choice is available with us. So, okay, 1 minute, I will take the attendance. Just wait for a minute. Okay. Shivani is there. हेलो
प्रेझेंट
शिवानी
सर.
आहे का?
हा सर.
तुला समजतंय का बाळा? डू यू अंडरस्टँड
हो.
what are going in the class? Okay, you pay the attention, you can ask the doubts at any time. Okay, you may call me or you can, anyone can call me, and you can put your query doubt on WhatsApp number, call up my number, right? Everybody is having my WhatsApp number. Okay, Hitesh is there. Hitesh. Vanita.
प्रेझेंट सर.
ओके, हितेश नाही आला का? हितेश धोबी. हितेश नाही आहे. ठीक आहे. हेमाली गिरणे.
प्रेझेंट सर.
हेमाली.
सर.
हा, ओके. तुला समजतं ना? निकिता.
हा सर.
Nikita is there. श्रीवर्ध
प्रेझेंट सर.
किर्ते. साक्षी मिश्रा. स्क्रीन इज विथ यू, हाँ आप देख सकते हो. प्रणील. प्रणील आला का? प्रणील. प्रणील.
तर तो
हॅलो,
प्रेझेंट
प्रणील इज
माहित
देअर.
तर
प्रणील आहे. ठीक आहे. परेश.
प्रेझेंट सर.
परेश आहे का? ओके.
प्रेझेंट सर.
आणि पांडे सौरभ. सौरभ.
प्रेझेंट सर.
उमेश पाटील.
प्रेझेंट सर.
उमेश पाटील.
प्रेझेंट सर.
उमेश. ओके. हा.
प्रेझेंट सर.
मिनल पवार.
प्रेझेंट सर.
ओके. मिनल आहे.
हो प्रेझेंट प्रेझेंट.
प्रतीक राणे. प्रतीक आहे ना? ओके. दर्शन.
प्रेझेंट सर.
दर्शन. ओके. प्रद्युम्न सावंत. सावंत
Present,
साहेब
sir.
आहेत का?
Present.
ओके फाईन. विनय शर्मा.
प्रेझेंट सर.
विनय. हॅलो विनय
Present, sir.
आहे. ओके. और यस यस विवेक शर्मा. विवेक. विवेक है क्या भाई? विवेक नहीं है लगता. ओके. साक्षी है. साक्षी शिंदे.
प्रेझेंट सर.
ओके. देन अनुराग शुक्ला.
Present, sir. Present.
विष्णुकांत. विष्णुकांत है क्या? विष्णुकांत. हाँ. जयेश ठाकरे.
प्रेझेंट सर.
जयेश ठाकरे आहे का?
प्रेझेंट
जयेश ठाकरे आहे. ओके. सुमित यादव. सुमित यादव.
प्रेझेंट सर.
ओके.
प्रेझेंट सर. प्रेझेंट सर.
ओके ओके फाइन. आई मेड इट प्रेजेंट. या संकेत शेवाळे. संकेत नाही आहे ना? ठीक आहे. संकेत इज नॉट देअर. हा विघ्नेश आहे, मला माहित आहे. ओके. सुजीत. सुजीत दास आहे क्या भाई? सुजीत.
सर.
सुजीत आया क्या तू?
हाँ सर.
ओके. वैभव मोहिते. हाँ यस वैभव मोहिते. वैभव. दुर्गेश कुडाळकर.
Present, sir. Present.
कुडाळकर.
Present.
ओके. या
सर अक्षय चव्हाण सर.
एक
सर अक्षय चव्हाण. फर्स्ट लेक्चर.
कुठे कुठे गेला तेवढे दिवस रे?
सर फर्स्ट लेक्चर आहे सर. प्रेझेंट सर.
हितेश is present, sir.
यस यस आई मार्डी.
सर अक्षय चव्हाण. सर हॅलो.
यस यस.
अक्षय चव्हाण सर. फर्स्ट लेक्चर.
हो हो ओके. So we will stop here only. Bye. Bye everyone. Goodbye. Goodbye.
झालं लेक्चर. हो ऐकले.